Hello, my name's Lynn. I'm the voice behind the videos, so you'll be hearing me doing some explanations for your functional skills maths exam at level 2. We've got lots of different videos in the series, all on different topics. I'd suggest for each of them you make sure you have a piece of paper, a pen and a calculator handy so that you can have a go at the questions as we go through. I always suggest that you pause the videos, take as much time as you need, and then carry on and have a look at the answers with me. Do always feel free to rewind and fast forward through any video so that you can either recap or skip to a point where you need a bit more explanation. We've got videos for all of the main topics, and in each of them we'll look at some of the methods and strategies to answer the different types of questions. We'll look at the wording of the questions, and we'll look at some practice exam questions for every topic so that you can feel more confident going to the exam that you know what you need to do. So join me in our upcoming video, and good luck for all of your exams.
So I'm going to take you through some of the questions on graphs, charts and tables in this particular webinar. We're going to be having a look at the types of graphs needed. We'll look at some of the features of graphs. We'll be stating how to draw graphs correctly on the exam and how to analyse them. We'll have a look at some example exam questions, and then we'll focus on data collection sheets, which is sort of a related topic, and it's something that people get a little bit confused about. For this particular video, so if you want to take part in doing the example exam questions, you will need to have some graph paper and a ruler to be able to have a go at those properly. You could just sketch them on some rough paper if you want to just have a general go at doing the questions, but obviously if you have graph paper you can have a proper try. A calculator might be useful as well for some of them. So if you want to grab the resources you need, and then we'll get going. So in the exam, you might be asked to draw a graph, to interpret a graph, or do both of those things. There'll always be one question that's based on a graph, a chart, or a table in there, but it could be any type of question, so you won't necessarily have to draw a graph. So when doing those, there's a couple of key areas that you have to consider. One is the type of graph that either you're analysing or you're drawing. The second is the scale. Third is the labelling, and the fourth is what statements you can make or what statements have been made. So any or all of those could be combined to help you answer the question. So we're going to take a deeper look at some of the types of graph that you may encounter on the exam. So you've got line graphs, bar charts, pie charts, scatter graphs, pictograms. So those are the ones that are the most common that you'll come across, and we'll take a deeper look at all of those. So we'll start off with bar charts. So bar charts are used to represent separate information. And I'll explain what I mean by separate information in a moment. Generally with a bar chart, you would expect numbers to be plotted on the y-axis and any other information to go on the x-axis. If you're one of those people that gets a bit mixed up between what the y and the x are, the x goes across, so it's horizontal, goes across the page because x makes a cross. So it goes across. Y is your vertical axis, it goes up the page. Another way to remember that is the Y has a nice straight stem, so it's showing you that straight line it makes. So the numbers will go up the vertical axis and other information will go across the horizontal axis. As an example, if you were plotting a graph of earnings in each month of the year, you would plot the months on the horizontal x-axis and the money earned up along the vertical axis, the y-axis. So the type of data that tends to be shown on the bar chart is normally something to do with number of. So it might be number of people visiting somewhere, number of cups of coffee sold, number of males and females. So anything where you can separate it into a number of something, that tends to be more likely to be a bar chart rather than a pie chart or any other type of graph. And a bar chart is chosen over a line graph if there's no continuation between the data shown on the x-axis. For example, a graph showing number of visitors to a shopping centre on Monday, Tuesday, Wednesday, Thursday, Friday would be on the bar chart because each piece of information there is separate. It's not continuous. There's no continuous relationship between the numbers on Monday, Tuesday, Wednesday. Fancy word for that instead of separate is discrete. So we call that discrete data. So if you're asked to choose the type of graph you draw, you need to think about whether that data is discrete, separate, or whether it is continuous. Something I always advise people to do, you've watched my other webinars, you'll note I always talk about checking units all the time. With graphs, check the scale. Always check your scales. So when you're reading your information, check what the scale or scales go up in. Might be a nice easy scale going up in 5s or 10s, 20s, 50s, 100s, but it could be a more difficult one, such as 0.25, or 4 is actually quite a tricky scale. So the first thing I do when I'm interpreting a graph is to look at the scale and check I know what each little division is actually worth. So I do advise that you pay particular attention to the scale. If you're drawing a graph, then make sure you use a nice easy scale for yourself. So that's bar charts. Take a look at line graphs now. There's two main types. One is the conversion graph, and the other is the one we were mentioning before, something that shows continuous information over a period of time. So a conversion line graph is a straight line graph, and you use it to do conversions. So you might convert between pounds and dollars, centimeters and inches, anything that has a fixed point to convert. So obviously pounds and dollars or pounds and euros, there's a fixed conversion point each day or each hour, depending on how you look at it. So that conversion will be a fixed number. Centimeters and inches, obviously that's always fixed. You can always use the same graph. And there's lots of other things you could convert between. So if you're asked to find information from these, very simple, you just read across and up to find the matching value. The only thing that can go wrong is that you start looking at the wrong side of the graph, the x instead of the y, or you haven't worked out what all those small divisions were. So let's just take a look at one of those. So we've got our conversion graph. You can see someone's actually plotted this one because you can tell the points that they've plotted on there. And our first questions, and these you can just try these out yourself, pause the video and then have a look on the next slide. We're converting between pounds and euros. Okay, so if you're ready, we'll have a look at the answers. So £250, so you'll be looking here to go up, read across, about 310 euros. I know you might struggle to see on your screen to look at the small divisions. 80 euros, so we're looking at this, the euro side now, reading across and down, about £65, and 300 euros, starting here, we're going across and we're reading down to about £245. And so that's how to read a conversion graph. And if you're drawing one, obviously you'll expect that there will be a straight line. So we mentioned that the other type of line graph is the continuous data graph. So this shows information usually over a period of time, and the time normally will go along your x horizontal axis. It's important, as I said before, that only continuous data is plotted on a line graph. If it's separate, use a bar chart. Take a look at pie charts now. So pie charts are plotted by splitting a full circle of 360 degrees into sections. Often you'll find the information is recorded as a percentage, with 100% being the full pie or the full circle, and that obviously makes it easier for us to understand. A pie chart will generally have a key to tell you what colour or design each section represents. If it actually does show you the percentages, then you can use your knowledge of percentages to work out the number of people or cups of coffee or whatever you're doing, as long as you know either the total number or one of the values. we'll just have a look at this example. You can have a go at the questions in a moment if you like. So here's a pie chart. It's got its title and it's got its key here telling us what all the colours represent, and the labels are all done in percentage. So we know by reading this first bit here, in the pie chart below, there were 300 visitors over 60. In the over 60s category, that's this light blue one here. So we know that 10% are the over 60s. So by knowing that information, we can then work out everything else. Because if 300 is 10%, then we can say 1% of the visitors would be 30 people, just dividing by 10. We can then multiply 30 by any of the other values to find out how many people visited in each category. So if you'd like to have a go at that, there's 3 questions to try. If you want to pause, we'll carry on the next slide. This could be quite a good question for those of you that want to practice your multiplication by hand rather than on the calculator. You could do that for this question. Okay, so having a look at the answers. 24 to 34 age range, this orange bit, 25%. We times that by 30 to get 750 visitors. 46 to 60 is 18%, this purple section. We times 18 by 30 to get 540. And how many visitors were over 40? 5. So this is one you have to just be slightly careful of. That means we're using both of these categories, the purple and the light blue. So we need to add the 18% that we worked out, 540, plus the 300 people that we knew from earlier to give us 840 visitors. I've seen quite a few people get caught out when they're reading over 45s, or it could have been under 34s, to make sure you include all of the relevant categories. One other thing with pie charts, they seem simple, but there's a couple of traps to fall into. This is another one. If you're comparing 2 pie charts, consider if you've been given the total values. This could influence how you compare the data. Often the pie charts will appear to compare the same amount when the data is actually very different. Just going to show you a very simple example on the next page, just so you can see what I mean. So you can have a go at this question and pause it after I've read it. So looking at the pie charts below, Jessica, the chairman of this business club, says that in 2014 they had 800 members in total. Barry says the pie charts show that we had more full members in 2015 than 2014. Explain whether you agree with Barry. So I'll let you have a think and have a go, and in a second we'll have a look at the answer. So, first thing I would do for this one is say, well, in 2014, Jessica tells us there were 800 members in total, so the whole pie is 800. Looking at the colours, we know that full-time members were 50%. 50% of 800 is 400 members. In 2015, if we look at the numbers, the full-time were 380 members. So that means that Barry is wrong, because he said there were more full members in 2015, whereas we actually know there were fewer. So overall, there are fewer members in total, even though there's a higher percentage of full members in 2015. So that's just the type of question that could initially catch you out, because by just looking at the pie charts without the numbers, you'd assume there were more full members in 2015 because there's 54% compared to 50%. So if you're doing a comparison question, always check the numbers before you start doing your comparison. Moving on to pictograms, unlikely to come up at level 2, but I have seen it before, so I just want to mention them because sometimes people are a bit confused about what they are. So a pictogram is a way of using symbols to represent the information in a very visual way. Common use is in holiday brochures to display hours of sunshine. Advantages of a pictogram: you can add to them over time, so they might be useful as a wall display in a cafe to show the most popular drinks. They're quite creative and fun. The disadvantage is it can be hard to display information accurately. They work best with rounded figures like 10, 20, 30, 40, etc. It would not be easy to display information like 12.2, 15.6, and very complicated information. The most important bit of your pictogram is the key. So the key is what tells you what each symbol represents. So if you're designing your own pictogram, you have to consider the key first. So it might be one sunshine is 10 hours of sun, for example. And the half a sunshine would then be 5 hours of sun. So very simple, but if you have got one of the exam, make sure you read it very carefully and look at the key. And just a very quick example. So the key obviously tells us that that sun represents 1 hour of sunshine. So you could count up for Tuesday, say 1, 2, 3, 4, 5, 6.5 hours of sunshine. Very simple. Scatter graphs. These are sometimes confusing. They're used for comparison and they're used for checking correlation. So correlation is a key word that's linked to scatter graphs. The most common use for a scatter graph is in some kind of experiment where you want to see if two factors are connected. To give you an example for that, you might want to know whether taller people have bigger feet. So you'd go around and you'd measure lots of different people to gather your data. You'd then plot a scatter graph. You'd probably plot height on the y-axis and shoe size along the x. You could do it the other way around, but we tend to do a sort of continue with a larger number data on the y and other numbers on the x. That's just standard. There's no real reason for that. Then we'd plot all of the people by plotting an x for each one, and then you could see whether there's correlation between them. And I'll show you what correlation is if you're not clear in a second. Sometimes the scatter graph will have a line of best fit. Sometimes you'll be asked to draw the line of best fit onto a graph. Sometimes it won't be possible to draw a line of best fit because there's no correlation at all between the data. If there's no correlation, there won't be a line of best fit. What you definitely should not do is try and join all the points up. So here's a scatter graph. It's the local ice cream shop, keeps track of how much ice cream they sell versus the noon temperature on that day. Here are their figures for the last 10 days. So the 10 days are the blue dots. You see temperature on the X and money on the Y. And you can see the orange line is the line of best fit. So it has been possible to draw that line. If you're drawing the line yourself, you want to try and draw something that roughly goes through the middle of the points. So you've got a sort of even number of points either side, but ignoring any what we call outliers. So if you had a point that was, say, down here, or that was up here, you would ignore that one and you wouldn't try and draw the line going somewhere like that. So you ignore any what we call maybe anomalous data or outlying data points. So that graph shows positive correlation because the line of best fit can be drawn from bottom left to top right. So if the line goes from here, bottom left, up to the top right, in this direction, then it is a positive correlation. If it goes from top left to bottom right, that's negative. So on a graph, if the line went from here down to here, that would show negative correlation. So one thing goes down as the other goes up. If the points are just scattered all over the place and you can't draw that line of best fit, then there's no correlation. If you're asked to make a comment about the graph, I would suggest state the type of correlation and say what that actually shows in terms of the information you've got. So from our ice cream graph on the last slide, the comment I could make is it shows positive correlation with more ice cream sold when the weather is warmer. So that would be my statement. So I've said it's positive correlation And I've used the two types of information, number of ice creams sold or amount of money from ice cream sold, and the temperature of the weather. So talking generally about graphs, I mentioned scale earlier. So on the line and bar charts especially, the scale is very important. If you have to draw the graph on the exam, there will be a mark for making sure the scale goes up evenly and it's appropriate, so it's a suitable scale for the information you've got. I always suggest that you plan your scale before you do anything else. Look at what the top number is, what do you need to go up to, and then think about what divisions you can count in. That's nice and easy to plot. So the easiest options are obviously 2s, 10s, 50s, 100s, 1s, simple things. So think about whether it's appropriate to use those. You can use any scale you like, of course, but I've seen a lot of people do really difficult scales, and then it's actually really hard for them to plot the graph because they don't actually know what all their small divisions are worth. So do think about how easy your graph will be to use. So have a look at the scales. There's 3 different scales there. What does each small division represent? So just to, that's a small division. So what's that worth? What's that worth? And what's that worth? So if you want to pause and work that out, on the next slide I'll show you what the answers are. Okay, so if we look at the first scale here, that goes up in 5. So 0, 5, 10, 15, 20, 25, 30, 35, 40, nice and easy. Next one's a bit harder, 12.5. So it goes 12.5, 25, that's the halfway. So as long as it can be working out what a halfway point is, then 37.5 and then 50. And over here 0.05, so 0.05, 0.1, 0.15, 0.2. So we've mentioned a little bit about statements, and I just want to go into a bit more detail on that. So often you're asked to make a statement to show what the graph is showing, or to compare 2 graphs. The way to make sure you get all the marks is to be as specific as you can, and think about referring to trends. You could also refer to the largest or smallest amounts. If you're not clear what a trend is what the graph shows overall when you look at the whole thing. So as an example, the graph shows that profits generally increased. So there may have been a couple of points where profits decreased a little, but the general trend overall is an increase. People lose a lot of marks when they're doing comparison questions because they don't actually do the comparison. So make sure you get that bit right by using words like than, whereas, and in comparison to show you're actually comparing. And we'll do an example of one of these. So I'd like you to make 2 statements to compare the sales and expenses in this graph. So perhaps pause at this point so you can jot those down, and then we'll have a look at a couple of examples on the next slide. Okay, so here's some examples of things you could have said. Again, there'll be lots of different ways you can express it. The key is that your statement has to have a comparison in there. So if you just said something like, expenses at first have a slow increase, then a sharp increase, and then a decrease, and you just stop there, then you wouldn't be comparing because you're not mentioning sales as well. So you have to make sure you have the comparison. So my first example, between 2005 and 2006, sales decreased, whereas expenses increased. My second statement, from 2006 to 2007, sales were increasing, whilst expenses were decreasing. And then when we're actually looking at the numbers, in 2004, sales were about 2.5 times greater than expenses. So I've actually used a little bit of knowledge of the numbers from this point to this point to say this point is about 2.5 times greater than this point. So there's quite a few other things you could have said or said them in slightly different ways. The key is that you use comparison words and you mention both sales and expenses in each of your statements. Just look a little bit further at this one in terms of labelling. So whenever you're drawing a graph, you have to make sure it is fully labelled. And I always say this a few times, there'll always be someone in the exam who loses marks because they don't label their graph. So by labelling, I mean it must have a title, and on bar, scatter and line graphs, there should be a label, like a mini title, for the x-axis and for the y-axis. On a pie chart, you need to label either your segments or to label your key. The label itself should tell the reader what that axis shows, even if it's completely obvious. So if it says January, February, March, April, you still need to put the label that says months of the year. If there's any units involved, then try and include those where necessary. So instead of just saying price, say price in pounds, or height in centimetres rather than just height. Because otherwise somebody won't know what you've measured in. Is it centimetres, millimetres, inches? So unless you tell them, they won't know. When you're interpreting your graphs, always check the labels. There could be a trick or hidden information within the label. Look again at the graph we analysed before. What were the actual expenses in 2004? What's the amount of expenses? Okay, and the answer is 400,000. If you just said 400, you didn't look here at the label. The label tells you that the expenses drawn on the graph are actually recorded in thousands. So this is 400,000, this is 800,000, and so on and so on. So each of these numbers, like this one, you'd add another 3 noughts on the end. So that would be 1.2 million. So just always read carefully, don't just assume. So a couple of top tips on drawing your own graph. First, decide what type of graph is best. There's a couple of differences between doing the exam on paper and online, because on paper you'll just be given a grid and you can generally draw however you like. Online, it's in some ways easier, in some ways harder. It's easier because they've already decided on the type of graph for you, just because of ease of creating the resource, really. So if it's a bar chart, you'll have the flat bars and you'll drag them up to the height you want by clicking and dragging. If it's a line graph, you'll usually have red crosses or coloured crosses that you drag onto your graph and put them in the correct places. So the type of graph is often done for you for online. Always read the question for any tricks. So check what they actually want you to draw. I've seen questions where you've got a whole table of information for, say, a full year, but they only ask you to plot the data or draw the graph for the last 6 months or the first 6 months of the year. As I mentioned before, don't start drawing until you've planned your scales. Don't forget to label everything, and do plot those points carefully. And once you've plotted them, check that you've plotted them correctly. If you're doing the online exam, I would suggest, if you haven't already, that you have a go at one of the practice ones, just so you can see for yourself how that works. It might again be a little easier because you've got boxes for the labels. It's sort of a visual reminder to put them on. Whereas when you're doing it on paper, it's all just blank, so you haven't got any clues that you need to remember to label your graph. So we're just going to see some examples of graphs, and I've actually used the exam software for these, just so you can see how it might look once it's done. For each of the graphs shown, I'd like you to decide how many marks you, if you were the examiner, that you would give to that graph. So here's the question. So a trainer wants to give Simon a certificate for meeting his swimming goal. The number of lengths is here, 4 weeks, Draw a graph or chart to display the data. 3 marks available. So you can see at the top here, I've just printed that table again so you can see what we need to plot. I'll let you have a look at this graph and decide how many marks out of 3 you would give it, and then we'll decide together how many we think it should be. Okay, so hopefully you've got a mark out of 3 in your head. Let's just have a look at generally what exam mark schemes give you marks for. So 1 mark would be for having any one of labels, plotting, or a correct linear scale. 2 marks for 2 of those things, and 3 marks for all of them. So let's go back and have a look. So labels, well, it's got the number of lengths on, and it's got the week number on, doesn't have a title. Let's look at the linear scale. So 30, 35, 40, but then it goes to 50 and then 160. So this scale is not even. If your scale is not even, then it's not a good scale. You won't get any marks for it. So we're not doing too well so far. Then we check the plotting. So week 1, I guess, yes, probably is at 30. Week 2, 35, yes. Week 3, 50. Week 4, 40. So that graph would get 1 out of 3 because the plotting has been done correctly, even though the scale itself was wrong. So let's try again. Let's have a look at another one. Another person's attempt at that same graph. I'll give you a couple of seconds to decide what you would give it, and then we'll look at it together. Okay, so let's look at the labeling. Well, it has got a title. It's got a label on the y-axis, number of lengths. It's got a label on the x-axis, week number. So we've got 1 mark so far. Let's look at how the scale goes up. 10, 20, 30, 40, 50. So that's a nice even scale. Includes all the numbers we need. Let's see if it's plotted correctly. So 30, yes, is shown there. 35, yeah. 50 and 40. So that has shown all of the information, so that would get the full marks on the exam. Now, some of you may be thinking about how the bars are actually touching. Now, really, the bars shouldn't be touching in a bar chart. They should actually have space between them. I'm pretty sure that in the exam, they don't mark you down for having bars that touch, but it is a good idea to keep them separate if you can remember to, just in case. And that's because we're as we mentioned before, we're trying to show separate data, not continuous. By them touching, we're perhaps implying that it is continuous data. And let's look at one more. I'll give you a couple of seconds again to think. Okay, so let's look. We've got all of our titles on, all our labels. Our scale goes 30, 35, 50, 40. So that's not going to get a mark. Week 1, 30 then. Week 2, 35, no. Week 3, 50. No, I don't think we'll be able to get a second mark there. So just 1 mark for correct labelling for that person's graph. Okay, and the final one. Again, just take a couple of seconds. So if we check labelling, no, only 1 label, so that won't get the mark. 30, 40, 50, 60, it goes up evenly and it includes everything we need, so that would get 1 mark. Week 1 is actually shown at 35, So that won't work. Week 2 is correct. Week 3, 50. Week 4, 40. So although they have mostly plotted accurately, because there was only 4 points to plot, they wouldn't get that final plotting mark. If there have been quite a lot of points to plot, sometimes you will get a mark if only one of them is wrong, or if it's only out by a slight degree of accuracy. So just 1 mark for that student. We look at another example now, but with a different graph. So again, decide how many marks you would give these graphs. So Phil's working out his earnings for different quarters. He wants to show his earnings as a graph or chart. Well, let's have a look at what's been drawn and decide how many marks out of 3. Okay, so for this one we've got quarters and earnings. Maybe and some examiners might give us a mark for that even if we don't have the title. Depends how generous they're feeling. If we look at the scale, what they've done is actually quite common. They've just copied the numbers from here onto the scale, not going up evenly at all, so no marks there, and they haven't plotted any points whatsoever. So probably no marks, maybe 1 with a very generous examiner, but very unlikely. Try the next student. They've managed to put a line on. Let's have a look. Let's see whether we think they'd get more marks. So we've got some labels. Again, no title. Maybe we'll get the marks. They have actually put earnings in pounds as well, so it's a little bit better. Let's say 4,000, 6,000, 8,000, 10,000. So that is going up evenly. Spring should be 4,500. So if this point is halfway, that's 5,000. So that's 4.5. So that's correct. 7,700. That's 7,000. These must go up in 2s. 2, 4, 6, 8, 8,000. So 7,200, 400, 600, 700. Spot on. 8,650, 8,002, 4, 600. About there. Quite hard to be accurate with some of these, so that's fine. And 5,400, 5,002, 400. So plotted accurately, accurate scale. Maybe we'll get a mark for the labels without the title, again if the examiner's feeling generous. This one, I just left in the cross there just to show you this is the cross you will drag down to make your points, and then the lines actually automatically join up. So we can see we've actually got a title on this one. We've got that same scale from before, so that's good. 2 nice labels there, and I think the labeling is the same. 2, 4. Yeah, I don't think anything's changed, so we just improved that one by putting that title on. So that would definitely get full marks. So here's some other exam questions. So these are the ones that you could try out if you wanted to yourself. And you can also take as much time as you need. If you've got your graph paper, you can have a go. For this particular question, also it's already started off. If you really want to try it as it is, why not do a screenshot and print that out? Otherwise, you could just generally have a think about where you'd plot those points on the screen. So I'll let you pause if you want to do that, and you may just want to do the section B, write the comment if you don't want to actually plot the points on the graph. Okay, so pause and then carry on when you're ready. Okay, so let's have a look at what we needed to do. So we developed graphs. So to get 1 mark, you need to either complete the scale or plot at least 3 points correctly. To get 2 marks, you need to do most of that, and you can make a sort of small mistakes to get 2 marks. For 3 marks, everything has to be fully completed. And then for the final mark, we're looking to talk about positive correlation, or the more posts, the more likes. So let's just go back and put that again, that comment. So because if we drew a line of best fit, it would actually quite nicely go through these points, and it would go from the bottom left to the top right. We can say the graph shows positive correlation, or we could talk in terms of the wording. So the more likes received, the more posts. To get the 3 marks first, we said we've got to complete the scale, and again, not everyone remembers to do this bit. We're going up in thousands, so it should go 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. Remember to go up to 7,000. Always make sure you've covered all of the points. Then 10, 20, 30, 40, 50, and 60. Got to finish it. And then complete the scatter graph. So for 18 posts, so we need to work out what these little divisions are. Let's just check. Are they going up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 18 would be here. And that's 2,300. So it should round if I want to add this on. So let's go 18 posts. 2,000, and do these go in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so 2,300 will be here. So we can add across at this point. Just going to see if I can pop that across on. Might be a little tricky. 1, 2, 3. Yeah, that's on. 43 posts. I'll tell you what, I'll just complete these numbers. Might be a little bit messy. If you did it, I'm sure it looks a little bit neater. 3,000, 4,000, 5,000, 6,000, and 7,000. So 43, 1, 2, 3, and 6,300. So I'm going up, up, up to 6,000 and 1, 2, 300. And then 32, 3,100. 25, 5,000. And 27, 4,400. Slightly messy there, but you can see the idea that we've got this positive correlation. I've completed the points, I've done the scales, so everything should be fine. Now if we just note again here, tolerance of one small square. So I could be out by sort of up here, a little bit more, or down there on them, and you'd still get those marks. So that's the sort of thing you'd be looking to do in the exam, to complete a graph and make a comment, or to draw a graph and make a comment. And we've seen how the mark scheme works there. So marks for completing the graph and marks for writing a suitable statement. Let's have a look at another graph. So the friends want to compare the highest and lowest scores for the bowling games. To draw a graph or chart to compare, and they give you some graph paper for this one. The friends want to know who's the most consistent in these games. Now this isn't strictly a graph question, this is an averages question, see, but I thought it might be useful for it to be in here, just because a lot of the average questions do tend to relate to graphs, tables and charts anyway. If you haven't already seen the video on averages, that will tell you how to work out this and what the word consistent relates to. And when we do the answer, I'll explain that a little further. So if you want to have a go at this one, either doing it properly or just doing a sketch, that's fine. We'll have a look at on the next page at what sort of things we could have done. Okay, so to draw the graph, again, we're looking for labels, plotting, and the scale. So if you did a sketch of your graph on your own, I hope you remembered to do the labeling, to say what those labels were. So the minimum labels, you don't have to use the full names like Andy, Bilal. You could use ABC, something like that. So you don't always have to be completely exact, so long as the rough idea is there. And it says here the vertical axis label may be seen in the title. So that means if you've put a title on but not a vertical axis, you may still get those marks, provided that you've included all of the information. So I'm just going to whiz on first just to have a look at what that graph should have looked like. This is the exam board's model answer. Yours doesn't have to go up in exactly the same scale, so long as your scale is even. And you may have decided to do it a little bit differently. But normally when it's in comparison one, it's a good idea to have either two colours or two tones. You could do, if you haven't got colours, do a stripy one and a plain one, something like that. Again, we should have the gaps between them, but they probably won't penalise you if not. And the names, and of course, we really should have labels. And they've actually done the label of colour there, but they haven't done the label on the y-axis. They have included that within their title. I think it would be best practice for them to have put the label there as well, but they didn't. So if we go back here, we're looking for the second part, who is the most consistent? So the answer was Dom. And to actually do that, consistency is a measure of range. So the most consistent person is the person who has the smallest range. So we could say, if we look at the bar chart, Dom's bars have the smallest difference in height. So if we're looking here, just to compare what we're seeing, Andy, there's his lowest score, there's his highest. So he did quite well here, but not as well here. So there's quite a gap between the two. As there is with Bilal, there's even, I think, probably a bit more of a gap with Bilal. So sometimes he got a really good score, but sometimes it was quite low. Cal's a bit more consistent, very similar. Dom, we can see the heights are nearly the same. So that is the consistency we're looking for. And Edie's got a massive range there. So we'd probably, although we'd do the numbers to check by working this out and subtracting it from this number, it looks to me that Edie is the least consistent, but I would always check those numbers. So you could say Dom, or if you've actually stated the ranges, you'd still get a mark for actually working out 3 ranges. It says give a reason, so you can't just say Dom. The reason is the wording, so the reason is Dom has the smallest range, or Dom's bars have the smallest difference in height, or you could say Tom's highest and lowest scores are very close to each other, something like that. That would be your evaluation. So if you haven't picked up on the word consistent meaning range, that is something to note down. So moving on to our next question. This is not a drawing graphs question, this is interpreting information shown in some graphs. So for this one, I'll let you pause the video and read it all through for yourselves, and then answer the question, in which month should they go? Just note it says you must give reasons for your answer. So 2 marks, and make sure you give reasons. I'll let you pause and that will carry on the next slide. Okay, so 2 possible answers, either October or November, would give you 1 mark. For 2 marks, November and a reason. So for example, you could say November is whale season. November is more than 15 degrees Celsius and less than 40 mils. So an example of how you could write it: November, as this is whale season, and there is less than 40 mils rainfall. Because it said reasons, it's good to have put both of them in, although it does say November and reason, so they would have probably let you get away with one of those. So do just make sure with that one, I think it was just a case of reading exactly what they needed you to put for the answer, not just putting the month. Okay, let's move on. Here's another one. This is one, again, if you want to have a go at drawing this graph, you can. If you don't want to draw the graph, you could just do part B, make the comment, or you could just do a rough sketch. So I'll let you pause to do as much as you'd like to, and then we'll have a look on the next slide at the mark scheme. Okay, so just have a look. Let's look at the 3 marks. So 3 marks would get correct labels on the graph, including either the pound sign or the amount, the quarters, the target and the actual. You had to plot the points correctly, and they'd let you go with 2 mils either way, and the scale has to be correct. So labeling, plotting and scale, as we've said. So if we just flick back, because it's a comparison one, it would probably make sense to do it a little bit like this one, with maybe 2 colours or something like that. One with the target, one with the actual sales. You don't have to use different colours or different points. You could just use different wording. So you could label each one sales target, actual sales next to each other. So if you don't want to do it with all patterns or colours, you can just use your labelling carefully to show that. Just being careful with your scale, because of these thousands, you could choose to take that off yourself and say pounds in hundreds or thousands, or you could just use the scale as it is, but just think about how you might plot it so you can fit the whole thing on. And then make a comment comparing the sales targets and the actual sales. So 1 mark if you make a simple comparative comment, such as Rick reached his target in Q3, and a good comparative comment would look more generally: Rick only reaches his target in Q3. So that's comparing obviously the sales to the actual. So it's a bit elusive, that one, hard to know what they're actually looking for. So if you can, make sure your comments are insightful comments. You could actually use the numbers if you like. So you could say that in the quarters where he doesn't reach his target, he is more than £4,000 away. I'm not sure, I haven't looked exactly at the numbers, but something like that. You might say that Rick is close to his target in 3 of the 4 and reaches it only in 1. So there's a few different things you could say, but make sure you are comparing the actual and the sales. If you just said something like Rick had the highest actual sales in Q2, you're not actually comparing the sales and the actual, you're just making a comment about the actual. So maybe a little bit trickier, that one, for the comment. And here's just an example of what it could look like. This is just a very rough sketch. So the actual is this sort of squiggly black colour. The target was here. Again, the only thing I would say is not leaving the gaps between the bars would be a bit of a downside for that one. It's got the label there, quarters. It's got the label at the top here, sales in pounds. So we know what it goes up in. And we've got a title at the top, graph of target sales versus actual sales. Without checking the points, they look vaguely to be in the right places, so that should get good marks on the test. Last section, data collection sheets. Mentioning it because people are usually a bit confused about what this kind of question is. So a data collection sheet is just a fancy name for a table, really, or a tally chart or something like that. Couple of different types of question. One is where they ask you to create this sheet, this table with some nice suitable headings. Sometimes you just create it, and sometimes you then fill it in using the data given. So you need to check which sort of question it is that you're doing. Are you actually completing it, or are you just creating it? A lot of the time you need to create some kind of two-way table. So actually you can check for the correlation of the information. So you might need to be able to record if a person is female and under 25. So is it possible to actually record the information? My tip is, once you've actually done your outline, just pick one piece of information and look at whether you could actually plot that or tally it or record it in your data collection sheet. Is it easy to actually put the data into the sheet? Even though you might not be asked to do it, just do it for one, or just pretend to do it for one, just to double check. So see an example. If you want to have a go at this one straight away, you can, but we'll also see what it should look like. So Josh is redesigning the local park. He wants to include a play area, a water feature, and a garden. And then for each of those, they need to choose an option. So in the play area, you can either have a slide or a climbing wall. For the water feature, you can have a lake or a fountain. In the garden, you can have roses or trees. He also asked people how many times each of the residents visits the park each month. And there's 3 options: 0 to 1, 2 to 5, 6 or more. He needs to record the answers on a data collection sheet. You've got to design it. This is one of those questions where sometimes I choose to leave them to the end, just because they can eat up quite a bit of time on the exam. Completely up to you, but I would just say watch how long you're spending on them. It's easy to sort of spend a while planning it out and then make a mistake and start all over again and just realise the time has whizzed by. So if you wanted to have a go before you see what we should be doing, pause now, otherwise we'll take a look. So you can see at the bottom right here, this is just an example. Yours doesn't have to look exactly like that one. But you could see how we could fill it in. So I ask a resident, what would you like to see? A play area, a water feature, or a garden? And I also ask them how many times they visit. So let's say they say water feature. I then say, would you like to see a lake or a fountain there? They say lake. I ask them how many times they visit. They say 3. So I would put my tally in this box. I ask the next person what they'd like. They say a garden, and they'd like to see trees rather than roses, and they only visit 1 time. So I put my tally here. So you can see that this one actually does work because you can record all the information in one go. So just think about when you do yours, is it possible to put the information in? And you can see for 3 marks, efficient, so it's got to work. Got to have the headings, so play, water, garden. Again, don't have to write full words, you can use abbreviations like S for slide. You can write them in full, it's just personal choice. You need to have the number of visits in, and obviously all of the opportunities. So you can see for 2 marks, it has got all of these things, but it might not be very efficient, so you might not be able to fill it in very easily. What a lot of people would do is then put 0 to 1 over here, so they have all the headings going along, which means there's no way to correlate them. So you'd have people here showing you which garden choice they want, but over here how many times they visit. So actually you can't put that all together. And it could even be a questionnaire for 2 marks. So it's not very efficient. So that's a data collection sheet, or in many cases just a 2-way table. So here's another one, and this one you can see actually it says design and complete. And because this is a 5 mark rather than a 3 mark, that's where the design part's probably going to be 3 marks, and then filling it in will be the other 2. And again, we've got these different categories, so you've got to decide how to set this table up to make the best use of the information. So if you want to have a go at this, pause it now. Otherwise, we'll have a look at what it should be like. Okay, so this is what it could look like, this part at the bottom here. So they split it into fewer than 6 trips and 6 trips or more. And you can see the style is to then have subheadings underneath. You don't have to do that. You can actually have this heading that said fewer than 6 trips and under 26. And this heading fewer than 6 trips and 26 years and over. So you can actually have 4 headings, but combining the different ideas. So that's absolutely fine. Now you could have chosen to swap the male and female for the age. So you could have the fewer than 6 trips and then this part here to say male and this part here to say female. And then the under 26 and the 26 and over to go here. So again, there's lots of different ways to do it. And then they've chosen to use a tally and then to put the numbers afterwards. If you are completing the table, it is a good idea just to check by adding up whether the total number of people you've put into your table is actually the right total number of people from counting the 18 people from here. So just to make sure it's all done correctly. So there are 2 marks for efficiently filling it in, and the other marks are for getting that table correct. And so you could, it sort of mixes them together as well. So you could have completing at least 2 cells or completing at least 4 cells correctly there for one of the 2 marks. Efficient table with headings for all of male, female, under 26, 26 and over, fewer than 6 trips or more. And again, the combination of those doesn't really matter so long as you can get the information into the table correctly. That's the sort of thing you'll be looking for. Just want to make one more point, just to be careful. Here, they actually gave you the headings for age under 26 and 26 and over. And if we look back onto this table, how many times is it 0 to 1, 2 to 5? If you're actually deciding on this part for yourself, just be careful you don't have overlap. I've seen people do things like 0 to 1, 1 to 2, 2 to 5, 5 to 6, or 5 or more, and then you actually don't know where to plot them. So if you were plotting 1, does it go in the first one, 0 to 1, or does it go in the second one, 1 to 2? So always make sure that there's an easy way to decide which box a number goes in. Don't have overlap between them. Otherwise, data collection should hopefully be straightforward. I know for some people who aren't very visual, they can be quite a difficult question. So that is the end. Just to bring us to the summary, always check your scale, either when you're drawing or analysing graphs. Plot your points carefully and then check you've plotted them correctly afterwards. If you're making a comment, think about whether you need to compare, and if you do use comparison words, always label as fully as you can. And just remember, if you see the word data collection sheets, it just means a 2-way table. And that's the end of graphs. So good luck with all of your graph questions.